Hello students, welcome back again to the mathematics class of class 7. Today I will make you learn chapter number 3, decimals. In the previous class we have already learned about the decimal. The word decimal has come from the Latin word decimus. What is this word, students? Latin word D-E-C-I-M-U-S, decimus, which means tenth. The decimal system therefore has 10 as its base and is sometimes called a base 10 system. This is called, students, tenth. This means 1 upon 10 and sometimes it is called base 10 system. A decimal is a fraction written in a special form. Instead of writing 1 upon 2, for example, we can express the fraction as the decimal 0.5, where students, one upon 2 is a fractional number and we can express this fractional number is in the decimal form. Students, where 0 is in ones position and 5 is in 10th place, isn't it? What is the place value of 0? 1 and place value of 5 is 10 in the decimal. So students, let's now briefly revise about the basic operations of addition and subtraction of decimals. Numbers of the form 2.364, 54.366 are called decimal numbers. A decimal number has two parts, the whole number part and the decimal part. These two parts are separated by a dot called, this is a dot called decimal. Whole number part is written on the left side of the decimal point and decimal part of this number is written on the right hand side of the decimal point. So this was about the decimal number. We use decimals every day while dealing with money, weight, length, etc. Decimal numbers are used in situations where more precision is required than the whole number can provide. For example, students, when we calculate our weights on the weighing machine, we don't always find our weight equal to a whole number on the scale. In order to know our exact weight, we must understand what the decimal value on the scale means. For that, students, let's first learn about the place value of the place value chart of the decimal numbers. Students, this is the place value chart of the decimal number. Suppose first to write a number 2, 3, 4, 5, 6, 7. We already know about the place values of the digits which are at ones place, tens place and hundreds place. But here it is the place value chart of a decimal number and I have written a decimal, that is a point after ones. And after ones it is tens, T-E-N-T-H-S, hundreds, T-H-S, thousands, T-H-S, which means 1 upon 10, hundreds means 1 upon 100 and thousands means 1 upon thousands. So let's write the place value of each digit after decimal. This is 5 and the place value of 5 will be 5 into 1 upon 10, which is equals to 5 upon 10, and if we write it in the decimal, it is 0.5. The next digit is 6. 6 into 1 upon 100 is equals to 6 upon 100, which is equals to 0.06. The next digit is 7. 7 into 1000 is equals to 7 upon 1000 is equals to 0.007. If you want to write the place values of these three digits that are before the decimal point, or you can say on the left hand side of the decimal, they are simple. We have already learned all these about the place value of the whole numbers. What is the place value of 4 here? 4 into 1, that is 4. 3 is 3 into 10, that is 30. And 2 is equals to 2 into 100 is equals to 200. So students, what we will read this number 234.567. We read the digits after decimal single or individually. So this was the place value chart of a decimal number. Now students, let's learn the like decimals and unlike decimals. Decimals having the same number of decimal places are called like decimals, and the decimals having the different number of places are called unlike decimals. Let's see a few examples, students. Like decimals and on the other hand side unlike decimals. Like decimals, students, let's take example. Suppose 23.012 and 16.222. So students, how many digits are there after decimal? 1, 2, 3. And here in this, students, there are also 3 digits after decimal. So these are like decimals. But students, suppose 213.579 and another number is there 21.36. In this, students, how many digits are there after decimal? 3. And in this 2 digits are there after decimal. So both are unlike decimals. So students, to compare two given decimals, we first convert them into like decimals. See how do we convert an unlike decimals into like decimal. Students, here are 3 digits after decimal and here are 2. So in order to make 3 digits after decimal, we increase a 0 there, and adding zeros after the last digit of the decimal part of any decimal number does not change the value of the decimal. So students, now there are 3 digits after decimals and there are also 2 digits after decimal. So these are now like decimals. Now students, let's start the questions of the learning check 3.1. Learning check 3.1. Let's see the first question. Which is greater? Question number 1 is of comparison. Which is greater, 0.5 or 0.05? Both the numbers are unlike decimals. Why? Because there is 1 digit after decimal and there are 2 digits after decimal. Now students, we will first convert them into like decimal by increasing 1 0 in this number. Now both the numbers have same number of digits after decimal. So now easily you can compare. This is 50 and this is 05 after decimal. So this is greater. Let's see one more question of this. Suppose, see third question. Question number 3, 7 or 0.7. Students, there is 1 digit after decimal and there is also you can write 1 digit after decimal. Now you can easily compare. We first compare the digits before the decimal. Before the decimal, that is on the left hand side of decimal, it is 7 and it is 0. So this one is greater. Now students, let's do the next question of this learning check. Which of the following is not a decimal fraction? See question number 2. First part, 60 upon 10. You can simply cut zeros of numerator and denominator. What is left there? 6. 6 is a whole number. It is not a decimal number. So it is not decimal number. See the next question, students. 15 upon 100. You can simply write 0.15. See students, how did I write 0.15? Because whenever we divide any number by 100, 10 or 1000, we shift the decimal from right to left of the numerator as many times as the number of zeros are there in the denominator. So how many zeros are there in the denominator? 2. So we will shift 2 digits from right to left in the numerator. And if no decimal is there, if we can't see any decimal, we assume the decimal here after the last digit. And what is the last digit? That is the digit at the unit place. It is 5. So after 5 we assume the decimal and we have to shift 2 place of decimal from right to left. So we will shift from 5 and 1. So where we have placed the decimal? Here before 1. So it is 0.15. It is a decimal number. Similarly, you can do the rest of the questions of this question number 2. Now students, let's see question number 3. Which of the following are like decimals? Question number 3, first part, 7.35 and 59.961. So students, you can see that here are 2 digits after decimal and here are 3 digits after decimal. So these are not like fractions, these are unlike fractions. Similarly, you can do question number 4. Let's see question number 5. It is based on the addition of decimal numbers. See students, question number 5 is add the following. The numbers are given like this: 6.75, 4.3 and 2.913. So you will first arrange all these numbers in column. How you have to arrange the students? In columns. That is, you have to arrange all these decimal number column wise. 6.75, 4.3 and 2.913. You have to make a point that the decimal should come below decimal, and we will make all the decimal numbers, or we will convert all the decimal numbers into the like decimals. Now add. By writing 0, we have converted all the unlike decimals into the like decimal. Now add 0, 0, 3, 5 plus 1 is 6, 9 plus 7 is 16, plus 3 is 19, 6 plus 4 is 10, plus 2 12 and 1 13. So the final answer is 13.963. Now students, let's see question number 6. Subtract the following. Question number 6. Subtract the following: 41.97 from 82.39. Now students, we will first write this number 82.39 and then below this we will write 97. We have to main focus on the decimal points, that these decimal points should come in a proper column. Now 9 minus 7 is 2, 13 minus 9 is 4, 1 minus 1 is 0 and 8 minus 4 is 4. Now students, let's see the next question, that is question number 7. What is asked question, students? Simplify the following. Let's see the first part of this. 32.532 minus 13.429 minus 6.5 3, 4, 1. Students, what you will do first, you will take these two decimal numbers, the decimal numbers with the minus sign. See in the rough, 13.429 and 6.341. We will write 0 here. Both the decimal numbers are of same sign. So we will apply the laws of integers. You can say that add these two, 9, 1, 10, 4, 5, 6, 7, again 7, 9 and 1 minus sign. So students, 32.532, write this as it is and write 19.770. Now you have to subtract 19.770 from 32.532. You can simply subtract by writing it here in the rough. 32.532 minus 19.770. Now subtract. 13 minus 7 is students 6 and 14 minus 7 is 7. 11 minus 9 is 2 and 2 minus 1 is 1. So what is left here? 12.762. So this is the answer. Now students, let's see the question number 10. What is to be added to 36.85 to get 71? Question number 10 is, let us suppose we add x. So according to the question, what is this students? 36.85 plus x is equals to 71, because the question is what is to be added? What is to be added? Let's x to be added to what? 36.85 to get 71. So mathematically this is this. The given question is this. Now you have to simply find the value of x. So you will transfer 36.85 from the left hand side of the equation to the right hand side of the equation, and the sign will get simply changed, 36.85. Now subtracting these two, we will get the value of the x. See here in the rough students, it is 71.00. You can write 20 after decimal in 71. And the number is 36.85. We have to subtract this. Now 10 minus 5 is 5, 9 minus 8 is 1, and 10 minus 6 is 4, and here it is 6 minus 3 is 3. So the value of this x is 34.15. So you can simply say when we add 34.15 to 36.85, we will get the value of the number will be 71. So if you want to check, then you can check it. 36.85 plus 34.15, add these two. 5, 5, 10, 8, 9, 10, 6, 4, 10, 1, 3, 3, 6, 1, 71. So